My name is Justin Bibb. I'm the mayor of the great city of Cleveland, Ohio. And I also have the distinct honor and pleasure to serve as the chair of Climate Mayors, a bipartisan group of mayors across the country focused on solely addressing climate change. We have an exciting session here this afternoon, all focused on how we do a better job as a nation in terms of decarbonizing the private sector. And before we do the deep dive panel here this afternoon, I wanted to give some context from my lens as mayor of a legacy city like Cleveland. For folks that don't know, Cleveland has been at the vanguard of the climate and environmental justice movement for over 4 decades. In 1969, we elected the first black mayor of a major American city, Carl B. Stokes. And I'm sure climate and environmental justice was probably not on his list of campaign priorities when he got elected in 1968. But a year after he was elected, we saw that our river caught on fire. And he crisscrossed the nation and did a nationwide pollution tour talking about the importance of clean waterways in cities like Cleveland, Detroit, and Pittsburgh. And because of his advocacy, that led to the creation of the Clean Water Act, which then led to the creation of the EPA. And so Cleveland, we can clap for that, by the way. There we go. So as mayor of the great city of Cleveland, Ohio, I feel a special moral obligation to continue the legacy of Mayor Stokes. And we got some big things ahead for us right now in Cleveland in terms of our efforts to decarbonize our community block by block by engaging the private sector in a very robust way. One of the great things we're excited about is the work that we're doing with Cleveland Cliffs. They are leading the global movement in green steel. And I think they're going to be a national and global model for how we can decarbonize the steel sector on a go-forward basis. The other thing we're really focused on is really making sure we're attracting and retaining good jobs, but also green jobs in Cleveland, Ohio. That's why we took $10 million of American Rescue Plan funds to solely focus on training and upskilling workers, particularly in black and brown neighborhoods, to lay down fiber and broadband, to weatherize homes, to decrease energy burden for our residents, all because we believe that these benefits should be broad-based regardless of where you live in our city. And so I think mayors are going to continue to lead the way, but we can't do it alone because we need active engagement from the private sector. And so I want to invite our panelist and moderator to come to stage. We have a great moderator for this session. Amy Harder serves as the executive editor of Cypher, and she's going to be leading this panel for us this afternoon. Let's give our panelists a round of applause if we can.
Thank you, Mayor Bibbs, for that great conversation and framing what is going to be an important conversation among our expert panelists up here. As the mayor said, my name is Amy Harder. I'm executive editor of Cypher News, where we cover climate technologies. And the technologies that are represented up here on stage by these experts is really the core of what we cover, the industrial emissions that make our society go round. Before we get to the introduction of the panelists, a quick raise of hands. Who here has walked on a sidewalk or drove in a car to get here today? Okay, everybody's hand should be going up. Now we can all appreciate why what these folks are doing really matters. And so a quick introduction to my immediate right, we have Stephen Gallowitz, Chief Commercial Officer of Sublime Systems. To his right, Lauren Faber-O'Connor, Operating Partner at Lower Carbon Capital. David Bierman, Chief Commercial Officer at Antora Energy. Rebecca Dell, Senior Director of Industry at ClimateWorks Foundation. And I'll let each of them talk a little bit more about what their companies or what their organizations do in this space. Rebecca, I want to throw it to you first. Can you give us sort of a 2-minute crash course on why industrial emissions matter?
Sure, and thanks so much for having me on this excellent panel here today. So the shortest possible answer for why industrial emissions matter is because there are a lot of them. depending on how you count it, industrial emissions are either a quarter or a third of all greenhouse gas emissions. If you're just counting direct emissions, so basically CO2 coming out of smokestacks at factories, that's a quarter of all emissions. And if you add in all the electricity that the industrial sector uses, it goes up to comfortably more than a third. So this is actually the largest sector of emissions. And if we don't solve this problem, we will not reach our climate goals. There's no way, the only way out is through. A very interesting and important aspect of greenhouse gas emissions in the industrial sector, which is, I think, reflected in this panel, is that while the industrial sector includes mining, manufacturing, construction, waste processing, literally millions of different types of activities and businesses, the emissions are heavily concentrated in just a couple of very, very large-scale industries. Foremost among them, steel, cement, and commodity chemicals. And commodity chemicals are basically the precursor chemicals, mostly for plastic and fertilizer. So those three industries together, that's 2/3 of all industrial emissions. And the reason for that is that those things, as Amy pointed out, are the ingredients that we use to make everything else. And so we make them in larger quantities. And because those industries are converting raw materials like iron ore, limestone, like things you actually dig out of the ground, converting them into useful industrial materials, you actually have to do a lot more chemistry in these industries than in the downstream manufacturing that uses these materials. And so what we're looking at is a huge amount of emissions, highly concentrated in a few industries, in a few major economies, and often highly concentrated in just a small number of facilities. There's about 600 steel mills, about 300 fertilizer plants, similar, globally. So that's what we have to focus on. That's what we have to transition to meet our climate goals.
Thanks for that, Rebecca. And I just want to underscore, these are the single largest emissions in terms of sector. It's not transportation, it's not electricity, it's industrial manufacturing emissions.
Actually, can I just add one little factoid on that?
Yes.
So if you think about all of the attention that we as like a climate community put on electric vehicles, so all passenger road transportation, so all of the vehicles that are currently being electrified, basically, all of the emissions from all passenger road transportation, that's about 9% of total CO2 emissions. That's actually about the same amount as either the steel industry or the cement industry. Steel by itself is as much as all the cars. Cement by itself is as much as all the cars.
And that's why these folks are doing what they're doing. It's why we at Cypher News focus on it a lot. And so thank you for expressing your interest and for being here. Lauren, as an investor, you guys are also very interested in it. I understand you're invested in both of the companies we have represented here on stage. So why are you drawn to this space? And what are the opportunities, but also challenges?
Thank you. It's great to be on this panel. And it is by coincidence, not by any influence that we had, that two companies in our portfolio are seated here. But I think that by the end of the panel, you'll understand why. From our perspective, so Lower Carbon Capital is an early stage venture investor in companies that are going to have outsized impact on the climate emergency and, of course, then outsized returns for investors. And when it comes to industrial emissions, our fund is a $2 billion fund across all decarbonization spaces, all sectors. And as Rebecca was just saying, when it comes to industrial emissions, in some ways, once you see it, you can't unsee it. It's everywhere. It's here, it's there. It's everywhere, embedded in everything, in everyday life, and everything we touch. And so from an investor's perspective, that's really exciting because those are huge markets. So that's kind of thing one. And from lower carbon's perspective, not only is it huge markets, but it's huge climate impact. And those two things are our North Star together. We don't do one without the other, and really what does it mean for the climate is why we exist. And so we know that there are massive markets, and we know that the companies that are going to solve these problems, they're being built right now, and they're going to essentially anchor civilization going forward. And so we know that these are going to be massively large, successful companies as we invest in these specific sectors. I know we're going to get deeper in a bit.
Great, thanks for that, Lauren. David and Stephen would love to dig into the folks really doing it on the ground. Stephen, let's start with you.
Great, thank you for that, and thank you to the Aspen Institute. Really happy to be here, and it's an amazing panel. So I guess a few additional add-ons to what the two of you have said. Cement is actually the most widely used material in the world behind water. That's an incredibly large number. We were just preparing our Series B deck, and one of my comments to our co-founder was, well, where's the total addressable market slide? And she looked at me and she said, we don't need a total addressable market slide. That's a crazy comment, and she was actually right. So a little bit about Sublime Cement. Sublime Cement is addressing the cement part of the equation that Rebecca talked about very well. I was actually surprised when I got involved. I thought all of the emissions from cement was coming from the hot kiln that was used to essentially boil limestone. In fact, that's only half of the emissions. The other part of the emissions is coming from the calcining of the limestone, converting the limestone to lime. The limestone loses half of its mass in the form of CO2, which is an incredible piece of information that I see a lot of you nodding. I didn't know this. I'm kind of a non-technical guy. That's why I'm on the commercial side. So we basically have developed, or my colleagues have developed, a very interesting technology to use, essentially battery technology, electrochemistry, to convert non-carbonate rocks, not limestone, but other kinds of rocks like a basaltic rock, and converting that into the same material, drop-in for ready-mix concrete, except at ambient conditions. Essentially, we zap it with electricity and dissolve the rock, is the short answer to that. Incredible technology, and the result is a zero emissions process, true zero emissions process to creating the cement. The amazing thing from this event, the prior conversations, I just came in from another fascinating conversation. There are so many lessons here already for how to do this well. So I've been in this industry for almost 2 decades, started in the renewable power space. And this is the next frontier. There's kind of frameworks, structures already for power, structures, frameworks already for transportation fuels. This is the new frontier and the new place where all of the action is going to happen, I think. I think that's why you've invested in us. And what we're seeing are tremendous numbers of borrowing precedents from the folks on the power side, from the folks on the fuel side, but also unique opportunities, particularly from folks like the mayor, who are showing the demand pull for these kinds of products. What I often like to say is that it's easier to pull on a string than to push on a rope. And that's the way we're approaching the market, because you have to see that demand pull, and when you pull on a string, it straightens that string. It straightens the supply chain on the way to the market. When you push on a rope, it just gets more twisty. And so that's the opportunity for the public-private partnerships and the unique mechanisms for bringing these things to market.
I love that metaphor. I'm going to repeat that again and attribute it to you, Stephen. So thank you very much for that. For these complex topics, it's often very helpful to have something very simple to visualize. So thank you for that. David, would love to go to you and hear all about Antora.
Sure. Well, thanks for the Aspen Institute for putting on an amazing conference and a super interesting panel. When we founded Antora, we just started with a very, very simple question. What is the biggest positive impact we can have on climate change? And when we studied the problem, and we studied the question, it was really evident that to answer it, you should go to some of the biggest drivers of climate change, and that is industrial emissions. And when you look at industrial emissions, you see the vast majority of industrial emissions are, in fact, associated with the heat and the power that are consumed at industrial facilities to drive industrial processes 24 hours a day, 7 days a week, 365 days a year. And that was really the challenge that we faced. How do you decarbonize the energy, the process energy that's going into these facilities? And remarkably, we're at a time where wind and solar prices have come down. And I know we're going to get into a lot more of the nuance there, and excited to talk about that. But this was a really powerful tool we saw, and a really major opportunity we saw to couple a new source of primary energy, renewable wind and solar power, into these industrial facilities through using a thermal battery module. So we're developing and manufacturing and deploying thermal storage systems that can effectively link this low-cost renewable electricity to address the on-demand, very power-hungry and energy-hungry requirements of an industrial facility.
That's great, thank you, and I appreciate all of these opening comments to really set the stage to continue our conversation. You've probably been in many other breakout sessions by now, but as a reminder, we will be taking questions toward the end, so please be thinking of things you would like to ask our panelists. But first, I get to be the one to throw a bunch of questions their way. First, another question for you in the audience. Raise your hand if you've heard the term in a headline or in conversations, hard to abate. Yeah, it's a pretty wonky term, but most of you raised your hand. This sector is what is often referred to as the hard to abate sectors. I think our panelists want to debunk that. We should all nix that entirely from our vocabulary. Rebecca, I want to start with you and your response to the hard to abate sector.
Yeah, so I hate this language. And the reason for it is twofold. I think it is both inaccurate and unhelpful. Let's talk about those separately. First, inaccurate. So when I look, in my opening comments, I mentioned that there are only 600 integrated steel mills in the world, only 300 ammonia plants. There's something like 2,200 cement kilns. We are talking. This is one of many reasons why transitioning this sector may actually be easier than other sectors. There's hard parts, there's easy parts. There's hard and easy parts about every sector, about the climate transition everywhere. What's different about the industrial sector, I think, is that we are at a much earlier stage of the work. In a lot of other sectors, when we think about electric vehicles, when we think about clean power, people started thinking about this and working on this like back in the 90s. And I think the industrial sector is maybe 20 years behind what some of these other sectors, and that does create challenges because we're trying to deliver emissions reductions on the same 2050 deadline as all the other sectors. But given that so little investment has been made in industrial decarbonization so far, and when I say investment, I don't just mean dollars. I mean time, talent, ideas, passion, policy, so little investment of any kind has been made. I find it quite cheeky for people to be like, oh no, this is too hard. I'm gonna throw my hands up and go home. It's not, don't say it's hard until you try. On the unhelpful side, I think the narrative I just gave you is exactly why this is so unhelpful. Because this language has been used for a very long time as an excuse for inaction by some of the laggards in the sector. And why should we use their framing? Why should we think about the problem the way the laggards think about the problem?
And just to add, when we hear from an investor's perspective that this is just early and not a lot of people are in the game yet, that's like perfect for a venture investor like Lower Carbon. That means that we have a chance to get ahead of the competition. That means that the companies that are going to help save this planet are going to win big because they're going first, and we can infuse them with the capital they need to go fast, to go early and fast. So it's not about hard to abate, and that's what gets us going. It's that it's early to the game, if you will, and that gives a really great and exciting and, if you will, unfair advantage to those investors that are willing to jump in with the companies that are going to get the job done.
So Stephen and David, as people really on the ground in these companies, do you find it hard, or do you agree with the comments that Lauren and Rebecca have made?
I totally agree. I think that was exceptionally well described. I think, and it actually reminds me of a comment you made in the very beginning of the session. Like, we can have this discussion about what's hard and what's easy. But the truth is, like, we have to abate all of it, right? Like, we don't hit our climate goals until we slash industrial emissions and all other emissions to zero. And I think people, particularly curious people, they like to kind of get in almost a trap of, I want to understand the nuance of what makes something so hard, and then I want to be able to talk about that eloquently with my friends. But I think, one example that we always talk about is industrial heat and high temperature industrial heat, and why that's so hard to abate.
And how high are we talking, just to level set with you? We're not talking 85 degrees in Miami. We're talking...
Yeah, we're talking about, the type of steam you might need to crack molecules at a refinery, or the type of heat you need to calcine limestone. This type of 1,000-degree type heat. But as a parenthetical, and this is important and totally on point here, like 2/3 of the industrial heat that's consumed in the United States is at 300 C or lower. That's certainly not hard to abate. But even these higher temperatures are not hard to abate. And going back to the advent of extremely cheap wind and solar, right? We have sources of electricity that have zero emissions associated with them. We already know, and have known for centuries, how to turn electricity into high temperature heat. That is how an incandescent light bulb works. That's how your toaster works in your kitchen. That's how electric arc furnaces have always worked. Like, that is not hard to do. We do it all the time. The challenge is we are trying to build businesses that can, as fast and as big as possible, deploy these types of solutions, again, to cut all industrial emissions, easy and medium and hard and ultra easy, to zero as fast as possible.
Another layer to this, when we say hard to abate, oftentimes that means expensive to abate. And this overlays with the topic of electricity. And so first, just to pose the relatively simple question, is it too expensive? Are these technologies currently too expensive? Why or why not?
Building anything small has diseconomies of scale. You couldn't build a cement plant using the existing incumbent technology at a small scale that would be cost competitive with the large scale. That is independent and has absolutely nothing to do with the technology itself. It's just smaller. And you got to get through that. There is a scaling factor here that's part of getting to big, getting to a mature industry. But there is nothing fundamentally about the technology that we have, that David has, that many others have, that is more expensive. And so you have to be looking at what does it cost to produce at scale, because that's the only fair apples to apples comparison. And there is a little bit of time that it's going to take to move to that point. We've seen this, though. There's lots and lots of great data points. If you look even just at the price of solar photovoltaics. I mean, the price has gone down way beyond what anyone ever would have imagined. Those are the same kinds of economies of scale and increases in efficiency that you can see over time in any of these technologies. There's tremendous amounts of data to support that. And so I definitely do not buy the idea that this is more expensive. There's a little bit of an upfront cost associated with it, sure, but that's really all there is.
I want to drill just a little bit deeper on that, and because in our prep call, you made an interesting comment, Stephen, that even if the cement may be more expensive in the overall construction of a building, for example, it's actually not a big share of the cost. Can you elaborate a little bit on that for the audience?
Sure. There's a lot of you have probably read Thinking Fast and Slow. There's an anchoring question here, right? When you're trying to present things to an end user, and if you're comparing the cost of the cement on a per ton or per cubic yard basis, it might look like a pretty large premium. But when you look at it as a percentage of the project itself, so the mayor's going to build a new building or a new bridge, from a percentage perspective on the entire project, you're talking about 1%. We're talking about really, really small numbers. And so you have to put these things into the proper context to be able to understand that. There's also sometimes, for certain technologies in this space, there is a little bit of a CapEx-OpEx trade-off where you end up having a somewhat higher CapEx, but that's compensated for by a lower OpEx. And so it's just different, and you need to understand that it's different. But that doesn't mean it's more expensive, it's just different.
Can I put a number on that? So for private construction in the United States, that is to say like buildings as opposed to infrastructure, the cost of the cement is less than 0.5% of the total construction cost on average. So it's literally a rounding error.
That's great. It depends on, you're building a data center, you're building a house, you're building a parking garage, but that's a perfectly
average
good,
number for private construction in the United States.
And it's an important reminder that for any of us moving into a new apartment building or renting a lease for an office, we're not going to face higher costs because of that green cement. Seattle, Washington, where I live, is building a state-of-the-art green aquarium holding massive animals with green cement. I was initially skeptical that they could afford green cement. I was naive, and that was just 3 months ago that I learned this. So thank you, Stephen, for enlightening us on that. I want to go to a related cost question and go to you, David, but also, of course, the whole panel, which is, although we've emphasized and underlined that industrial emissions are the largest single source of emissions in terms of the different sectors, there's so much overlay and overlap and interdependency. And what I mean by that is that in order for some of these technologies to work as intended, and I would put Antora in that category, we need a lot of clean energy. And that clean energy should probably be as cheap as possible. And David, you mentioned that earlier, but would love maybe to have you start on this. Why is having so much clean, affordable electricity important? And if you've attended some of the other sessions, we've talked about how that is not a guarantee. There's a lot of concern about growing new development projects around the country. Can you talk about why that's important for a company like yours? And maybe Lauren, want you to jump in after to talk about, as an investor, that's a 2 to 3 degree separation from you, but you also need that.
Yes, I can talk for a long time about this, but I won't. I think we should start just with a reframing. So, we are in the midst of this unbelievable transformation. And let's just say it clearly, and then we could talk about it. Like, wind and solar in certain parts of the world, at certain times of the year, are the cheapest source of primary energy that humans have ever encountered. Full stop. And 2 of the largest sectors of the economy, which we talked about, transportation and the power sector, are undergoing trillion-dollar transformations right now, basically because of this phenomenon. And third, industrial emissions, or addressing industrial emissions is the third $1 trillion or bigger opportunity, where we're buying trillions of dollars every year to buy fossil fuels and burn fossil fuels to make stuff. And it is, could not be a better moment to introduce the types of technologies that can soak up this extremely low value primary energy source and use it for this application. So now we can get into like, do we have enough? If you go to a place like Kansas, for example, or all over the Midwest, you have wind farms dotting the landscape, right? Spitting out gigawatts of wind power. Does anyone know why there's so much wind power there? Because it's freaking windy.
That was a trick question.
It's super windy. And you know, wind development in those regions has stalled out. And it's stalled out because when the wind is blowing, you're generating electricity, your neighbor's generating electricity, their neighbor's generating electricity, and there's no guarantee that there's actually demand on the grid for that electricity, right? And so this creates a big issue. This creates congestion problems in the network. It creates curtailment events, which are, you know, first, like, you just say, oh, shoot, we built this wind farm and we're not actually generating or using wind power. That's sad, and it makes your heart kind of hurt. But another very important aspect is that no one's going to finance the next wind farm, right? Like, why would you do it? The risk is too great that half the power you're going to generate is going to be tossed out. And so Antora is really like going right at this problem and saying, look, you need to co-locate these facilities right next to a major industrial center. And then when you have that wind power that there is no greater use for, there's no higher value to use, you're going to send that power over to us. And we're going to pay for it, but we're going to pay a fair price for that based on the market value of that power. And we're going to use that to couple the power sector into the industrial heat sector. And so we're going to use that to basically feed our thermal batteries to be able to, on a 24/7 basis, give the energy required from the industrial facility. So the point there is a technology that has a very flexible and low-cost way to soak up intermittent electricity can be a very strong enabling force for new wind and new solar development as we hit these points of saturation and some of the pain points on the grid that we're going to talk more about.
An interesting, I think, dynamic to the fact that industrial sectors are sort of going next in the decarbonization life cycle is that the innovations are able to better respond to real-world circumstances and better respond and integrate into the transformation that is happening around that sector. So David gave a great example of how, all right, we are solving for a few problems, actually. We're solving for like that emissions problem that we've known about for a while, but we're also solving for increasing the economic viability of this other set of solutions that have been, you know, developing itself for a long time, being this issue of, you know, intermittency and curtailment as a result. And so we're actually seeing a ton of innovation across multiple sectors, whether it's in industrial heat, steel, cement, other places where, especially as you're getting into lower temperature applications, like we have a green steel company in our portfolio where not only are they looking at sort of low-grade ores that have much lower environmental impact, but actually they understood the intermittency problem. They said, well, we're gonna build a company and build a product that actually takes advantage of that and solves that problem at the same time. And so by operating actually at lower temperature, it doesn't matter if they kind of turn off and on to take advantage of when the low-cost renewable energy exists, because they don't have to deal with what ultimately would have been, you know, ramping up and down in temperature, which essentially means you're never going to turn off. And so you can't really do that. So they actually are designed to integrate into this as a solution, which only helps their economics, which helps the pace of their development. And it's really taking advantage of what we know needs to be a much more integrated system to address the climate problem.
how easy is it to co-locate industrial facilities that need this heat that presumably already exist next to this excess renewable energy? Is that something that's easy to do?
Yeah, it is. So 2 points there. One is if you just look at the existing fleet of wind and solar, you will find 50 to 100 gigawatts in the United States alone of 24/7 industrial heat loads. Just think a boiler that's running all day, every day, burning natural gas. That's within 25 miles of an existing solar or wind farm. So first off, like, do that right now. Secondly, like, if you look at where industrial centers are, they are and have always been and will always be placed in a place where you can find the cheapest feedstocks, primarily energy, right? That's where they are. And so when you go into a new paradigm where you have abundant levels of the cheapest primary energy we've ever known about as humans, that's where you're going to find new industry build out, guaranteed.
Rebecca, you made a comment in our prep call about how you sort of reject the idea that these types of technologies are more expensive. And I think we've heard part of the reason why that is. But can you share what happens if we don't have enough electricity down the line? And let's remember, electricity is being asked to do a hell of a lot in our energy transition. It's going to power our cars, our heating, our industrial sector. There's a lot of demands on this clean energy.
Yeah, so this is actually something I worry a lot about, and I think that this is not like tomorrow's problem, but this is definitely a problem that is only going to get more serious if we don't address it sooner rather than later. Because I think a lot of people don't really understand just how much, or they haven't internalized. They can't feel it in their sternum, like just how much energy these industries use. So just to kind of give you a sense, the industries we're talking about, steel, cement, chemicals. Sometimes people put aluminum and other kind of primary commodities in there. They're often referred to collectively as energy-intensive industries, and we're not joking when we say that. So like one steel mill, not a notably large steel mill, just maybe like a 3 million ton a year plant, something like that. We've got bigger plants than that, smaller plants than that. That's 10% the size of the world's largest steel mill. If fully electrified, it would probably have an average load of something like 3 gigawatts. So 3 nuclear power stations to power one steel mill. So this is just...
I wonder what the math is, how many wind farms and solar farms it would require to do that.
Yeah, a lot. And so like this is not a situation where you can just like buy a piece of equipment and plug it into the grid. Like you have to plan the grid, and you have to, and to David's point, you have to site your facilities with the idea in mind. Where can we get the best access to the energy we need? And the industrial geography that we have right now was done with that in mind, but for fossil resources. So what that means is that some of the sites where we're currently doing heavy industrial production will be appropriate for electrifying, because they will have the transmission infrastructure or can build the transmission infrastructure, are close enough to the renewable resources or other clean energy resources. They will be able to adapt. Others are going to have a much harder time, and there are going to be places with really high quality renewable resources that are not currently industrial centers, where there might be pressure to develop heavy industry in the future. I think a great example of a place that's got a lot of heavy industry now and will also in the future is Texas. It's got all of the fossil fuels and also all of the renewable resources, as best I can tell. But not every place is going to be like that. And so that's something that we have to be in. But when we talk about these problems, we're really focusing on the most energy intensive processes. So we're not saying that like all of the manufacturing needs to go, but we are going to have to think about this, and because these transitions are the kind of things that take 10 or 20 years.
So I have 2 comments. First of all, I think Lauren's doing the right thing here. you want to skate to where the puck is going to be, not where the puck is right now, right? And so understanding where are we going, what's the trajectory, and then backfilling other synergistic business investments that all work together in a cohesive kind of worldview, I think is the thing that makes a lot of sense here. That's the first thing. The second thing is, in the interim, there is going to be some competition for green electrons. And I think we're going to increasingly start to hear a lot of resource allocation discussion with a different kind of a metric. And that metric is, for the marginal green electron, what is the biggest bang for the buck on CO2 reduction? That's going to be something not a lot of people are yet talking about, but I think we're going to hear a lot about that in the next year or 2 years, because this is an issue. And as we're moving this thing along, you want to put those green electrons to the places where you're getting your biggest bang for the buck.
It's Bitcoin mining, isn't it?
No, it isn't. But I just wanted to second that.
That was a joke. That was meant in irony. I hope everybody caught that.
I totally agree with that framework. And we talk to major renewable developers day in and day out, and this is exactly where the conversation goes. I'm going to build this huge asset. It's going to produce some finite number of megawatt hours, and I am going to optimize where every single megawatt hour goes. They don't think about it as decarbonization potential, but it is linked to basically how I get the highest returns with the lowest risk.
In just a couple of minutes, we are going to throw it out to you in the audience, so please be thinking of questions as a reminder. The Washington Post just did an incredible story on this very topic, talking about how there could be a risk that we will run out of electricity, talking about the demands of not just Bitcoin mining, which I still don't understand at all, but also artificial intelligence, which is going to help us all, but also will, as we all know too well, going to have a lot of challenges as well. So I recommend checking out that article just from the last few days. I want to turn to something that we actually haven't talked about, but has been a big topic of the conference, which is, it was funny, Secretary Granholm last night, at one point she said something, Bill and Ira, as if it's two people. Somebody needs to create a meme that has Bill and Ira. Of course, she's referring to the Bipartisan Infrastructure Law and the Inflation Reduction Act. Cypher actually ran an article a few months ago about how these industries represented up here, you've sort of fallen through the cracks of the IRA in terms of really direct, significant support. So would love to hear your thoughts on how of course, it's all interconnected, so you're going to be riding the coattails of the support other sectors are receiving. But would love to throw it out to the panel. One, how is it affecting your business in this space? And two, sort of a related government policy, going back to your great metaphor, Stephen, about pulling the string instead of pushing the rope. Who is a good puller of that rope or that string? The spoiler alert's the government. So would love to hear about the role of government procurement if there's no direct subsidies for your technology. So that's a lot to unpack, but anybody want to just respond to any of that I just said?
Well, first of all, I would say there's lots of good things in Bill and Ira, and I think there are lots of great opportunities there for us. There are some elements where there's a lot of talk about carbon capture and sequestration. That sucks up a lot of the oxygen in the room. Maybe not the CO2, but the oxygen in the room. But there's tremendous opportunities in Bill and Ira, and we're super excited about that. And it is a meaningful thing for us.
Nothing bad to say about Bill and Ira.
Absolutely not. But I would also say that there is a massive source of funding, which is government procurement. Government's spending the money anyway. They're buying the cement, maybe not directly, but indirectly in all the projects that they're building. That massive pool of funding can be monetized to building plants like ours in a whole variety of very interesting and innovative ways, whether it's just borrowing the credit from the government through offtake agreements to enable project financing, or other more interesting and innovative solutions. Laura and I were talking about that earlier today, some some things that we're not really seeing yet, but I think there's so many levers out there for creative minds to figure out ways that the government can drive change here and catalyze change.
Well, just going to add, in terms of government procurement or the role of government, less on the incentive side, but on that demand pull. I mean, in general, whether it's government or private sector, I think that they're sort of underestimating the role they have in pulling technology forward by sheer show of demand. And show of demand can be done in different ways. It can be these kind of long-term commitments to procure the material, the thing, the product when it arrives. Like that sends a huge signal to investors to sort of demystify where the demand is coming from. And I think that folks are sort of almost doing themselves a disservice who do want to procure it but are not realizing like they can get off the sidelines and do a little bit more to show their demand without kind of having to put them between a rock and a hard place and really make a big difference in terms of the ability for these companies to grow. On the public procurement side, for example, my previous role before joining Lower Carbon Capital was with the City of Los Angeles. I was the Chief Sustainability Officer for the City of LA. And so, everything we were doing is like looking at what levers do we have. A city like Los Angeles has many levers because we own and operate a municipal electric and water utility, among many other huge pieces of infrastructure like a port and an airport. And government procurement at a city scale, actually, we were seeing could move markets. And we were also doing work to aggregate our demand and say, we're going to team up with other cities and show that jointly together, we would purchase, again, insert decarbonized product. And so, we want that to come. And we were really doing that through a few different levers, but procurement itself, putting into our RFPs, these are the things that we want to see. And that means industry has to go out and find it if they want to win the bid. And then once you win the bid, then it becomes other cities say, oh, I didn't know you could do that. And it smooths out some of those, some of that friction. So yeah, it is a real opportunity for folks that want to be in a leadership role to be proactive.
I do want to throw it out to the audience, but Rebecca, if you had a quick comment.
Yeah, I'll add a couple of numbers. I feel like that's my role on this panel. So the first thing is on the public procurement piece, my friends on this panel have already made the case very persuasively, but I'll just say here in the United States, we estimate about 45% of all of the cement is purchased with taxpayer dollars. So particularly in the cement industry, the number for steel is about 20%. It's different for different commodities, but particularly for cement, public procurement is like, that's the market. The other thing I'll say is that I also think that that Bill and Ira are wonderful, and I'm so happy that they're our friends. But in my opinion, the IRA is significantly underpowered in the industrial sector. The industrial sector can benefit from some of the very broad provisions in it, like for clean electricity and clean hydrogen. But in terms of dedicated funding for industrial decarbonization, there's only about $10 billion in the IRA out of about $400 billion. And that's for a sector of the economy that's 30% of our national emissions. That seems like not enough.
So some room for improvement for Bill and Ira.
Yeah, whatever the third friend in the clique is, it's going to be all industry.
Chip,
I hope it's Rebecca.
Yes, we all hope it's Rebecca.
That is a tough acronym to pull off.
Oh, but you can expect a lawmaker will do it because they love those acronym laws. So we're going to throw it out to you in the audience. I think we have mic runners going around. A couple quick requests there. Please keep your questions to a question and relatively quick so we can fit in as many questions as possible. Why don't we gather 2 questions and then our panelists will tackle, let's do these 2, actually let's do this cluster of 3 folks right here. Let's hear each of their questions and then we'll ask the panelists to respond.
Sure, thanks. Chris, I work in policy in DC, thinking a lot about these questions. The third friend of Bill and Ira. My question is specifically on industrial sectors, thinking about the types of tools, in particular for things like production tax credits. If you can speak to the ways in which that you're thinking about those or those types of policies can be developed to support what you're doing.
Great, and let's actually take 2 more questions and then we'll come back to that question. Thank you for that.
Thanks so much, everybody. I really appreciate the time. My name's John Peeler. I do clean energy investment work. And one piece of the story that I'd love to understand better is as you guys are climbing down the cost curve, up the adoption curve, you're selling to a group of folks who I presume this room is not chock full of. I don't think we have a bunch of steel plant owners here. And
Raise
I'm
your
curious,
hand, any steel plant owners? No.
I would have loved to see it. But in the absence of that, I'd love to hear about the conversations you're having with them to spur on adoption, given that while end-use customers aren't facing materially higher costs for them, I presume it's a harder conversation. And I'd love to learn from your experience.
Great question.
That's a great question. Thank you for that.
Hi, thank you. Stephen, I think you briefly touched upon this topic, that's carbon capture and sequestration, because I feel that in any panel about hard-to-abate sector, we end up there. And so I would be very curious to hear your take about it. Is it like there to stay? Are we actually gonna like decarbonize these sectors without this? Is that distracting us, pushing back the problem? Thank you.
Thank you for taking us there. I was going to take us there at the very end if you didn't, so appreciate the flag. So we got a question about the production tax credit, how it benefits the sector, conversations with direct customers for these products, and then carbon capture. Stephen, why don't you answer? You were getting ready to answer the first gentleman, if you want to take that.
Sure. So production tax credits can be an incredibly strong motivator. I mean, this was what drove adoption of solar and wind and landfill gas. I built a lot of landfill gas plants that were built based on the production tax credits. We would love to see something like that, and we think it would be highly effective. You need to be a little bit careful with tax credits because you need to have someone who has tax appetite. And there have been a bunch of structures that have evolved, tax flip structures and things like that to enable that. But we're strong supporters of production tax credits. We think they make a tremendous amount of sense. And we are seeing some of that at the state level. So there are some states that have started to adopt production tax credits in some other spaces, sometimes biochemicals, things like that. I think Iowa has one, maybe Minnesota. So we're seeing this in a bunch of places.
I can take the second question. I think it's a really good question about the question, just to rephrase it, is, what about the end user, like the actual plant you're selling green steel or buying the feedstock to go into green steel or buying steam that's decarbonized and whatnot. So we, again, going back to the founding of Antora, like really studied this question and it has a lot of implications on business model and exactly how we're going to go to market. And we feel pretty strongly that the role of the industrial, like you have to meet them where they're at, right? They have to run a cost competitive business. They're typically selling in commodity markets. And so, cost and reliability are king for those guys. And so what we are doing is selling a product that meets the reliability and the cost metrics that compete directly with natural gas. We talk about a green premium, we talk about what we need in the early days. Like, we actually don't really talk about that a lot at Antora because we are like laser focused on how do we get as quickly as possible to a point where this is actually just a much cheaper and more reliable solution than the alternative. In my mind, and I'd like to talk to others about this, like that is the only way we are going to do this fast enough and at the scale we need to decarbonize industrial emissions. So what that really means for us is not that our customers are taking early tech risk or putting down huge amounts of capital to deploy these projects. It means that we have the right financing partners in place who can understand exactly where we're heading and want to be supportive throughout the way. So that's like capital partners both at the corporate level, but also project finance and infrastructure partners who understand that. And the way that we've sort of designed the product is to be as close to solar, wind, and batteries as possible, which is to create a very, very modular system that you build over and over and over again as fast as possible. So we could do a gigawatt-hour project, and that would require us to build a thing like 200 times. And then when we do the second gigawatt-hour project, it's not our second project, it's our 201st to 400th time doing that thing. And that is the type of, that sort of modular strategy is the type of approach that our financing partners can get really comfortable with, because they understand exactly what it takes to put these projects together. And that gives us access to the cheapest sources of capital, which allows us to really build that cost-effective product, which might be just steam cheaper than natural gas to the industrial customer.
Rebecca, would love to throw the carbon capture question to you, possibly also Stephen, but this actually came up in our prep call. There's general agreement that let's not talk about carbon capture, but here we are, and I agree, it comes up all the time. So Rebecca, I would love to hear your quick thoughts on that.
Sure. I'm happy to talk about that. So, okay, here's the very, very high level how I see carbon capture in heavy industry. The first thing is that I see very little opportunity for carbon capture retrofits at existing facilities to achieve high capture rates. That's just technically going to be incredibly difficult. If you want to achieve high capture rates, you typically have to build the plant with the carbon capture in mind. So the idea that this is like a technology that we can sort of slap on at the end of pipe and continue to use equipment in substantively the same way we're using it today, in most of the meaningful applications, that doesn't feel like a particularly good idea to me, or a particularly plausible idea to me. That being said, if we are going to use carbon capture anywhere in our economy, we are probably going to use it in the industrial sector. And the reasons for that are simple in some cases and more complicated in others. They're actually simplest in the cement industry, where Stephen pointed out that half of the CO2 is coming straight out of the rocks. And so all the clean energy in the world doesn't get rid of that CO2. And there are process emissions, those kind of chemical reaction emissions that don't come from energy, in many, many industrial sectors. So I am not anti-carbon capture, but it doesn't seem particularly cheap or easy to me. And I think that we probably should be pursuing it as one of a basket of solutions. And I will also say that when you actually look at like what are the innovative technological investments that the incumbent firms are making, with basically one company excepted from this, that company is Heidelberg Cement, the actual investments that, when incumbent firms are putting their own money into clean technologies, they're not putting it into CCS right now. And so that my attitude is like, well, if they're not pushing for it, I'm not going to be the one to tell them they should.
Do you have a quick thought from the cement industry?
So
Stephen?
first of all, I agree with everything you said, and we're not against CCUS at all, right? Where it makes sense, people should do it. I guess, in our view, true zero, which is what our process is better than net zero. Just makes more sense to not create the emissions in the first place. I do sometimes joke that carbon capture is sort of like the cow tipping of this industry. Everybody knows somebody who went cow tipping, but they've never actually done it themselves. And there is no YouTube video about cow tipping. If it was really a thing, there'd probably be a YouTube video on that. So, I think Rebecca's point is there just isn't that much uptake on it yet. And, the market will determine that at the end of the day. But we're not against it at all. It takes all yes and, for sure.
We are about out of time, so I want to go to our concluding lightning round, but hopefully the panelists might be able to stay for some questions after, if we have more questions from the audience. Concluding lightning round where we do first word association. So I'm going to say a word, and our panelists, since we're mostly out of time, we want to keep it very brief. So just say the first word, can be any word at all that pops into your head when I say the following words. And the first one is carbon price. There's no pressure.
Growing.
Rational.
Irrelevant.
An important part of the value.
Trust me, you're not the only one to disobey the rules, so it's okay. Former Secretary Ernest Moniz is terrible at this game, for example. If anybody knows him, you know he's not succinct.
World-class pontificator.
Yes. Carbon capture.
Cow tipping.
Sure, fine.
Valuable.
An intrinsic cost.
This has been a very US-centric conversation, but of course, it's not called global warming for no reason. With that preface, China.
Super important.
I'm going to break the rules, but more than half of all the industrial production.
In the world.
Not to be ignored.
Insecurity.
Ooh, intriguing. Okay, and to bring us to a close, net zero by 2050.
Faster.
The goal?
Let's do it.
Believe it.
Great. Well, thank you to our panelists and for the audience.